For our demonstration of Creo Simulation Live, we're going to be working on a motorcycle dataset that we have here from one of our customers, Royal Enfield. More specifically, I need to work on the rear arm subassembly. This is a model that we're working with. It's in active development, trying out different features, different parts. What I'd like to have is feedback from my analysis to gauge the design decisions that I'm making while I'm making them. So we're going to go up to the top here and click on our Live Simulation tab to get started. Now, over on the left-hand side of the screen here, we see we have all our studies managed in the simulation tree. In this case, I'm interested in a structural use case where we have our constraints and our loads laid out. In terms of constraints, we have a lot of options. We can have certain displacements predefined in the model. We also have constraint types like ball, planar, cylindrical for more specific use cases. From here, we can take a look at some of the loads that we have set up in the model. Loads can be forces, moments, pressure, gravity, centrifugal forces, linear acceleration, really a lot of options. And with any of these, change the values, change the units, really anything that you need to go through and set up for your particular use case. And with everything laid out, we're ready to simulate. And in traditional systems, if we wanted to analyze this assembly, we'd typically have to go through and defeature the model, get rid of small holes, rounds, interferences, define all the different contact points. But with Creo Simulation Live, we don't have to do any of that. We just stay right here within Creo Parametric and check out the results from the study. In this case here, over in the legend, we can see what kind of von Mises stresses that we're getting. We can even highlight on minimums and maximums to see exactly where we're getting stressors or hotspots. Over here on the model, we're getting the most stress where the bracket is connecting back in on the main body of the assembly. We can also take a look at the deformation that we're getting. We can get a good idea of how the model is reacting based on how I set my study up. We're also able to animate on the deformation, which lets us very clearly see if the model is responding in the way that I intended. Now, based on some of the initial results we got back, I know that I'm most concerned with the von Mises stresses that we're getting. Now, to get a better understanding of those stresses, let's use a simulation probe. Simulation probes allow us to monitor certain values that we're interested in and see how those values update as we make changes to the model. So right now we can see we're at about 165 megapascals of von Mises stress. We can see how this value changes for every design change that we go through and make in the future. Let's go ahead and do that now. Let's see what we can do here to lower down the amount of von Mises stresses that we're getting. My first idea is to update the profile of our sweep here. Maybe we'll try out more of a straighter edge at the top by removing that rounded piece of the sketch. All right, that's looking good. And since I updated the profile of the main body, I'll also update the profile towards the front end of our assembly here. And one of the biggest benefits that we have here of working with CSL is that we don't have to switch between different software or even different windows. It's the same place that I'm doing design. That's the same place that I'm getting my simulation results back. We can go ahead and make any changes that we need to. And what's clear throughout this is that I'm still going through here and doing some normal Creo parametric work. But as I'm going through and making changes, we're instantly getting feedback from Creo Simulation Live to say whether the changes that I'm making are moving my design in the right direction. We can see here that we've dropped now our von Mises stresses down to around 129 megapascals, and we can always open up that simulation probe, check back on those values for each of the changes. Now maybe what I'd like to do now is move into more of a drastic change. I want to see the effect of increasing the overall width of our rear arm assembly. Well, as soon as I make that change, we simply just update that back here in my simulation live study and have all the surfaces update, all the stress values up in the legend update as well. So I'm not just making a change and hoping that I'm moving in the right direction. We're immediately getting feedback from CSL if we're lowering down our max stress values. In this case here, we've dropped it to around 90 megapascals. With that, there's no guessing. We can take that value, compare it to where it came from, and start to guide my decisions going forward. What's great is because I've gotten that quick feedback from CSL, we can now go through here and try out different profiles, new design ideas, really start to explore many different design paths. So in this case, I got some good results from that straight edge profile. Maybe now I want to try out a bit more round or more circular profile for the part along the edge. So very quick to go through, swap out those sketches, just using some standard Creo sketching functionality. And that's looking pretty good. But again, we also want to update the profile at the end of our swept blend up towards the front end of the assembly. Just make sure that it matches up well with the rest of our part here. With this, we're just simply going through and replacing the original lines with new ones, which will make sure that we maintain all the different relations between our different parameters and our features in the model. Again, very quick to go through and make the different design changes that we need to make here on our model. Once we've gone through and updated the profile sketches, we can go back and update now the results that we have back in our assembly. And that's one of the big things to notice here is normally we'd have to do all the defeaturing work, build out a mesh, or ship it off to an expert analyst to even get some basic results back, when all we need to know is whether we're moving in the right direction or not. In this case here, we definitely seem to be moving in the wrong direction, up to around 182 megapascals of stress. So instead of manually going through and trying out lots of different values for that profile, let's instead let Creo do that work for us. Let's do a sensitivity study, which is part of our behavior modeling extension. This is where we can select on different values that we want to iterate on. We can set a range of possible values for those. And instead of us iterating through and seeing how that changes our maximum von Mises stress, we can tie this back in with our simulation probe from Creo Simulation Live. Now for each value that we're trying out here for our profile sketch, our sensitivity study goes through, changes the dimension, and graphs out the von Mises stress that we see in the model. And once the sensitivity study and Creo Simulation Live give us the value at each step, we can now see that the lowest von Mises stress was right around a value of 13.75. Now using that information, we can head back into the part and make those changes. And we got to the optimized value really much faster than we would have doing it by ourselves. Now that's less time that we spend messing around with values, trying to get something that simply just works. Now what we're able to do is get to the most optimized part, the most optimized feature while we're designing. It's not something that we're thinking about as an afterthought. It's a mindset that we're working with right from the start. And that's a big part of the story here. Rather than us just going off of gut feel and intuition, let's get real-time feedback from Creo Simulation Live to help us determine if we're doing the right things. And as we've seen, we're able to do it in an interface that's very straightforward, something that designers and engineers are going to be able to get up and running with very quickly. As we can see here, getting results back very quickly. Now we have our stress values down under 100 megapascals, definitely moving in the right direction there. Same thing with the deformation, we're lowering down these values, and we can keep working with this all throughout the design. And at this point, once the design might be a little bit closer to the finish line, we then have the option to switch over to our more traditional FEA tools, such as Creo ANSYS Simulation, for getting our final validation analysis. This brings over all the loads and constraints we had in CSL, and we can take it to the next level as we start to get closer to a finalized product. But overall, what we're able to do with Creo Simulation Live is take insight from our analysis tools and integrate it into every step of the process, not just as a pass or fail, but truly working towards the best design possible.